HackTheBox has coding challenges now. And this is something that there's a bunch of new ones that are coming out on a weekly basis, and they're not retired yet, so I can't spoil them or do them live. But there's a few old ones. Some of them I think come from older CTFs where maybe they were under the miscellaneous category or something. But they're retired, and we can make a video with them. So I went and grabbed the hardest retired one, which is a medium challenge called Insane Bolt. And we're going to dive in and try to solve this one today. There's a bunch of easy and very easy ones. And if you think that'd be interesting to see, especially if I can take it from more of a beginner level, leave me a comment because I could certainly make videos of those if there's interest. But for now, we're going to hit Insane Bolt. So the prompt: this insane scientist wants to craft the most powerful android in the world. He help him collect many bolts to achieve his goal. He needs many diamonds to make it even more strong and powerful than any other android. Good luck, adventurer. Let's go ahead and dive in. All right, so I've got an IP address and a port. We'll go ahead and paste these in and connect with Netcat and see what we're dealing with. Instruction seems like a reasonable way to go. We got to help the robot reach the diamond. You need to find the shortest route. You need to collect 500 diamonds and at least 5,000 bolts. The solution should be given in the format DLR, down, left, right. So if we hit play, these are kind of ugly. I wonder if this is a sizing issue. No, not really. Okay, so here's the robot. There's a path through these bolts, presumably to get to the diamond. I'm guessing I can walk on bolts, but not on skeletons or fire. And let's go ahead and give it a shot. I'm not even going to try to figure this out with the spacing all off. Let's go ahead and open up VS Code, and we can take a look at what we're dealing with. I do trust me. I will create a solve.py. Now, we're going to use the pwn tools library. And specifically, we're going to use the remote. So we do from pwn import remote. And that gives us functions like receive until, send line, things like that are just useful for interacting with a socket. Because it's a third-party thing, we're going to run it with UV. So we'll start with the shebang. User bin env -s uv script. No, UV run script. And so that shebang is going to give us the ability to run with UV. I'm also going to just close this real quick, and we can, I just had my most recent video about how to put inline metadata here so that UV can just run it in its own virtual environment. So we're going to do UV, I'll include a link to that here or here over my face probably, so you can watch that if you haven't. It's really useful for how to install Python, but and run Python-based stuff. All right, so UV add script. The script is going to be solve.py, and we're going to add pwn tools. And now, if I come back here and open this again, the dependencies are now added in line. And that means I can UV run solve.py, and boom, I just installed pwn tools into a virtual environment and ran it. If I run it again, you don't have to install the 33 packages. It's just there. So much better than what I used to have to do before by creating a virtual environment, installing into it, etc. Even better, because I have this shebang line here. If I change mod plus x solve, I can now just run solve, and it runs as well. And it knows to run it using that same UV virtual environment. Super cool. Okay, let's get back to the challenge. So let's do import sys, and we're going to need to, let's see, if len sys.argv is not equal to 3, print f usage sys.argv 0, that'll be whatever the calling program was, and then IP port, boom, like that, and then we will sys.exit. So that should work. We can come back here and solve.py, we get that. If we do blah, blah, boom. Okay, we're going good. We can now say remote is equal to remote sys.argv1, comma, sys.argv2. And if we do r.interactive like that, that's not the right port. Where's my, boom. We connect to interactive. We can play the game. Perfect. Okay, so now what are we going to do? We don't want to go interactive. The first thing we need to do is tell it we want to play. So we're going to r.receive until, and we're looking for this right here. So we're going to read up to this prompt right here. And then we're going to r.sendLine like that, the number 2, and that'll get us the puzzle. So let's do that. well, I guess we can't, we know, so the puzzles are going to come next. And if we look, we can scroll up actually, that would be best. If we look here, really we want to read again until another prompt where it's asking us. So we can do data equals r dot receive until bolt bam like that. Okay, so now we've received our data. We're going to get the solution. How we get the solution? We're going to say that is equal to solve maze on data. Worry about solve maze later. Then we're not exactly sure what we're going to send the solution. So we'll do r dot send line solution dot encode because we got it in bytes. And now we're not really sure what's going to happen. So we will just do a breakpoint right here. And now we got to implement solve maze. Eventually, we're really going to wrap this in a loop. So it's going to look something like, let's see, while true there, and we're going to loop around. This might even just work, but that's the basic structure of how our attack is going to work. Because you said we have to get 500 diamonds, and we get 1 per maze, so we're going to have to do this a bunch of times. We could probably do this over 500 loops if we wanted to, but it just feels, anyway, we'll go with this for now. Okay, so let's come down here and we'll do def solve maze. This is going to take in data, which is bytes. It's going to return a string. The first thing I want to do is get out of this Unicode. And let's go ahead and we'll do breakpoint right here, and we will run this, and we'll see what it looks like. So if we do this again, and here we have data, it is a mess. Each of these Unicode, like 6 bytes things are, there's a 4-byte one, are these different emojis. And I don't want to deal with that. I can't loop over that. I mean, I can, but it just feels messy. I want to get out of it. So what I'm going to do is I'm going to say, we're going over here and we'll say, emoji map is equal to, and I'm going to pick this first one. So if I do, what did I do here? Data.encode. Nope, I did mean that. Decode. We can see that it actually does decode. So we have new line, and then fire right here at the end. So this one right here is fire. Cool. So I'm going to take this up here and put, when I see that, but I need that to be like a wall. And in a lot of these kind of coding challenges, a wall is often like a hash symbol. So we'll just go with that. I could come here just to be nice about it. Copy this and put myself a fire there. Let's put a comma here. Boom. Okay. So now what I can do is I can say for key comma value in emoji map dot items data equals data dot replace key comma value. Boom. Okay, so now let's get out of here. Let's run this again. Oop, a bytes like object is required. Not this has got to be make that bytes. Save. And boom. So if I do data, you can see down here I've got these pound signs where I used to have a long thing. So if I do data dot decode, I've replaced all the fire with pound signs. That's cool. Okay, so I have all these pound signs. This first one right after that new line is a skull and crossbones. So let's grab this. Come here. We will do this. So we'll say, oh, we need to do that. B, paste there. And we want to place that. Now, the skull and crossbones is basically the same thing. It's a wall I can't walk through. So we're just going to do the same thing. We're going to put that there, comma, put that, and we'll put our skull and crossbones in just so we have it. You don't really have to do this, but if I cannot copy it, maybe we're not going to do it. Boom. Okay. Let's run that. We'll quit. Run again. Data. Looking good. We got lots of walls here. Decode. We can see the next thing we get to here is the diamond. And it's pretty close to this new line. So this right here is the diamond. So let's come here. And this one is our endpoint. So we'll do this, paste here. What do we want? We're going to call this one, I'm just going to call it E. We can call it whatever we want. And we'll put the diamond here. And this is not necessary, but it looks nicer. What else can we do? The bolt is up this next one, and we can see the bolt repeats a bunch, ending in A9, so that must be this one. So we'll grab that, and we will paste there, and that is going to be a path. So I'm going to call it P for path, and we can put, and again, don't have to do this, but copy, paste that there. And the last thing we need is the robot, which is at the top. And that must be this one right here. So we'll grab this. And we will be boom, boom, oops, boom, boom, B start and comma. We've come so far. Let's make it look nice. Boom. Okay. So now if we save this, we quit here, we run again, we print data. Let's do print data. It's looking closer. These spaces feel annoying. I think we can get rid of spaces. So let's do B space, B nothing, and quit and run again. It'd be helpful if I put that there and run again. We have data, print data dot decode, and boom, that is a maze. You can see now that one I can solve, right? Down, left, down, down, left, 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 bunch of downs, etc. So we get to the endpoint. I've got solvable stuff here. This is cool. Okay. So I've got that. I've got my data done. I'm going to do a little bit. I think we're going to do a little bit more. I think I could work off of data like this. I could split data into lines and do rows and columns and work off of it. But I think it's going to be a little bit worth our while to do some processing up front. So I'm going to go ahead and make myself a, we'll say, path spaces equals, and that's going to be a list of my spaces that I can step. Now we can do a loop over our data. So we'll say for, we'll call it row, comma, line for in enumerate, and this will be data.split lines. What I'm going to do, enumerate, so data.split lines is going to split all these into their own objects, into line by line. And then enumerate is going to say, give me the first line 0, the second line and 1. Well, third line will be 3, then or 2, then the third line, etc. And so I can do the same thing here. I can say for c comma ch in enumerate line dot. I'm going to go ahead and do right here. Go ahead and not split, strip, just to get rid of any trail. Split lines will leave the new lines at the end, and I don't want those, so I'm going to remove white space with that. And so now basically I'm going to walk over each row and coordinate with its R and C value, and I'm going to be able to check what it is. And so I can say if ch, which is the character, in, I should probably, let's see, we should go ahead and data equals data.decode. Let's go ahead and let's work in ASCII. So if I'm at the start point, the path, or the end, so if ch is one of those three, then I'm going to go ahead and say path spaces dot append r comma c. And I can say if ch is equal to s, start is equal to r comma c, elif ch is equal to e, end is equal to r comma c. And that's basically all I need. When I leave this loop, I'll have the start point, the end point, and all of the path spaces. I can come here and say assert start is not none, assert end is not none. You don't want these assert statements in like live code, but for a CTF or when you're building something, it's super useful just to make sure I'm assuming at this point start and end are populated. If I get here and they're not, I don't want to keep going because things are going to get weird. I don't just tell me troubleshoot. Just tell me right now it's broken. Okay, so now we've worked all this out. We're going to do a breadth first search. And what's cool about breadth first search is the way it works is you build it, you get a queue. And the first thing you put in your queue is going to be an object of state at some point. And so when we start, the only state's going to be my position is here at this S, and I've moved 0 spaces. And then what I'm going to do is I'm going to say, okay, from this S, I got 4 ways I could move: left, right, up, and down. I'm probably never moving up, but we'll give it as an option. And I'll check each of those. And if any of those are valid moves, I'll add them to the queue. And so in this one, the only valid move would be the down one. And so the next thing that gets added to the queue is the coordinates of this space, this R, this C, and now the path before was nothing is now D. Now I go back and I take the first thing off the queue and I look all the options around here. And there's actually 2 things I'm going to add. I'm going to add this one and this one. And both of them will be, this one will be DL and this one will be DR. And those both go in the queue. So all the possible steps that are 2 away are now in the queue. And so I grab the first one off and I get all the ones that are 3 away from that. And I keep track of visited so that I can't, once I'm here, I can't go back to where I was. I can only go, because if I'm looking for the shortest route, I'm never going to go back. And so then I can check all the things that are possibly 3 steps away, and then all the things are possibly 4 steps away. And what that means is when I get to the end, I can stop right there because I know I found the shortest route. So let's go build that. How how are we going to build that? So we're going to go here and we're going to say we're going to need a queue. We'll use the thing to use for this is from collections import deck. And we're going to go ahead here. Let's go ahead here and say what our state. So I always like to just write what my state is. It's going to be RC and path. So we'll say Q is equal to deck that, like that. And now we're going to have RC. Oh, actually, this is going to be start. We're going to use the splats to break it out. So we have start. And then the path is just going to be an empty string because we're going to keep the string as the path as a string. We'll also say visited is equal to a set like that. And now we're going to say while Q. First thing we're going to do is we're going to pull our first state off the queue. So we'll say RC path is equal to Q dot top left. We get the first thing off the stack. Okay. First thing we're going to do is say if R comma C in visited continue. Otherwise, visited dot add R comma C. Okay, so now this is how we're keeping ourselves from making sure we don't go somewhere twice. Now that we've got that, I guess we can also check. No, we'll check for end later. So now we'll look at each place we could go. So we're gonna need another map here. We'll say direction map equals, and we will do down, and down is going to be in ours, R gets higher because this is our 0, 0 up here. So to go down is +1. And we're keeping it row column. So we're going to do 1, 0. Up, I don't know if we're going to do ups, but we'll -1, 0. We'll try it. Left, I don't think it's going to add that much time, and it's going to just keep us from screwing up in the future. Left is going to the negative, so we'll say -1 like that. And then right, it's going to be 0, 1. And we got them. So now we can say for move comma drdc in, what do I call it, direction map dot items, and that'll give us these 3 things. So that'll be move rc or drdc. So now we can say next r next c is equal to r plus dr c plus dc. If nr in c is equal to end, we found it. We're there. So return path plus move. So path will be the string up to that point plus the move that gets us there. If not, then we'll say if nr and c in path spaces, that's it. And that's good enough. We'll just do that. We could do a check here for visited, but I don't think we need to. I think it'd be fine just adding these and immediately calling them off when we get up here. So if it's a path space, if we are allowed to go to that next space, we will say q dot append, and what's our state? It's going to be rc and then path plus move. And that's it. I mean, I think that's really all we need. So we're just going to keep doing this loop, and this could solve it for us. I'm sure I made some error in here, but let's give it a try. We'll save this. We'll quit here. We'll run. None type has no object encode. We should never get to. Let's go ahead and check. Let's do this. Raise value error. Ran out of spaces to check. Is that what we're hitting? Yep. Okay. Let's see what we got here. Let's do this. Let's do something right here where we print Q. We are never getting anything in the queue. Let's breakpoint. Okay, let's see. What does path spaces look like? Okay. And what is R, comma C? Did I return? Bang R. R is 2, bang C. 2, 6. So 3, 6 should be in here, right? Yep. What did I do? Oh, okay. We're gonna append next R and next C. That's almost certainly our problem. So I was appending the wrong state here. You're supposed to append that next state. So let's see if that fixes it. I should get rid of this breakpoint. Quit. We gotta go quick if we want to actually solve it. That looks promising. So what did we just get here? What have we done? We got a solution back here. We sent it. Solution looks like that. We've sent it. Let's go next data. We got something here. Okay, look, it says at the top, you have 1 blah, you have 15 blah, and then it gives me another thing. So there's double new lines here. So let's do this. We're going to go here and we're going to say result equals r dot receive until, and we'll do new lines like that. Let's make it bytes. And then we can print results decode. And I think that's going to work. Let's give it a shot. Look at that. We're getting results. We're solving them. Every time I continue, you can see we're getting another diamond and a bunch more bolts. Let's make this a little prettier. How can we do this? Let's see. Let's make it, first of all, let's make it 1 line. So we'll say print recalls decode strip split on new lines. And then we will do a space dot join. So all I've done here is I'm stripping off white space on the end. I'm splitting on this new line in the middle, and then I'm rejoining it back with a space. So I'm replacing that new line with a space. That's probably that's probably a better way to do it. Let's do it that way. Replace on the space. Let's run that and see how that looks. Beautiful. Okay, so that looks good. Now, do this. We will get rid of the breakpoint. Spending too much time being cute with this, but this is the kind of thing I like doing. So you're gonna have to humor me for a second. If I do a /r at the front of that, and then I do an end equals like that, and I put a print here, we are gonna get, I think, we're gonna get it printing. Yeah, see how now it's like updating as we go? That's the stuff. Okay. At some point this is gonna fail, and I don't know how. So we may have solved it. I mean, the fact is, if the flag just comes out right here, we're gonna have it. So I guess we have to wait for this to get to 500, but you know, in general, the secret here is just this breadth first search, and we're solving puzzles over and over again, and then we're earning these diamonds. I'll probably go ahead and speed the video up here to get to the point, and we'll see what happens at the end. All right, here we go. This is going to be the moment of truth. Let's see what we get. Congratulations, this is your reward, and we crashed with an end of file error. Okay, annoying. All right, let's grab this. I'm going to go ahead and do, let's say, if we say if, nope, that's not what I wanted. Let's see. If that in results.decode, oh, yeah, okay, decode, break. Then we're going to print r dot receive all dot decode. So we should just get whatever is left, whatever comes. So whatever happened here, we were trying to read up until a new prompt, and instead we hit an end of file and we crashed. We could also put this in a try. That might be the easier, that might be the safer thing to do actually. Try that, and we do step EO file error break. Do that. Get right here. And then we can receive whatever's left, decode it, and print it. And we'll call it, see, this is going to have to go here. And let's go ahead and run that again. I will speed this up so you don't have to sit through it. All right, let's join back in here and hopefully see our moment of triumph as we get the flag. Boom. All right, we got it. Congratulations, this is your reward. We received all, we closed the connection, and boom, there is our flag. So, fun challenge. Please, thank you so much for staying to the end. I appreciate it. And let me know, do you want to see more of these challenges? Do you want to see more of these easier? This was a medium level one. It wasn't too hard, but you definitely had to understand breadth first search to solve it. You want to see? I don't know what the easy ones look like and the very easy ones, but we could probably knock them out. So let me know if you'd be interested. Thanks for hanging out with me today. Talk to you next time. Bye.